This is our 354 Lab 13 case study, and we will be doing it on a motorcycle water pump. My name is Joseph Choi.
I'm Jackson Kamidolski.
And I'm Keegan Moster.
So what is a water pump? Well, in our case, this water pump can be found on the Honda CRF 250R dirt bike. And what it does is it helps maintain engine temperature so that you can keep dirt biking and having fun. So how this is accomplished is there's an impeller within this water pump that keeps rotating, and that creates a suction of air, and that allows it to pull water throughout a reservoir from the pump into the engine, and thus allowing you to maintain your water temperature. And then once that water goes through, it's channeled back into the pump, and the cycle continues while your dirt bike is within operation. And now Jackson will go over into more detail of some of the machine components.
So the three machine components we chose for this water pump are, the first one is the rolling element bearings. It's a ball bearing, and this allows the bearing allows the impeller to freely spin, and that way it can actually push water through the pump without very much friction, and that's how basically it operates. Next is the gear. The gear is used to transmit the torque that ultimately spins the impeller. And then finally, the threaded fasteners that are used, which are the bolts on the outside of the covering. And this not only secures the pump onto the side of the engine, but it also helps keep all the water inside and makes it function. And now I will pass it to Keegan, who will go over some more of the purpose of this pump.
So what are you getting out of this pump? So like Joe had mentioned before, the main purpose of the water pump is to maintain an engine's temperature during the use. So while you're riding around out on trails or out on a race course, you're using the engine quite a lot, and you want to help maintain the temperature to keep it nice and cool so you can continue to use that engine for a long time. So in this case, like we again said before, the impeller, which is this picture shown on the right of a typical impeller, is used to push water through the system and to pull it back through the system, and then just to continue the cycle of water moving through the engine block. This impeller is on the same shaft as the gear, which we said before was powered, and which we will say again is it's powered by the engine, so that it has a constant rotation. There's continual water going through. And so since these are on the same shaft and are rotating at the same speed, we would say that this part of the machine has a 1-to-1 advantage. So here is our diagram of it, a little bit simplified than the previous one. So starting from the right goes the gear, next the bearing, and then the impeller, and then the next piece is the cover, in which case the water would go out the top of the pump cover, and then lastly you have the threaded fasteners on the very left. So next we'll go a little bit more into the three components that we chose.
So this gear is responsible for generating most of the work and making sure that the water pump works in the first place. Without the gear, the water pump would just be an impeller and nothing would really happen. So the engine drives torque, and that allows this gear to rotate, and that is what provides that 1-to-1 ratio and rotates the impeller that allows that air to be sucked in and the water to be channeled through to spin.
So the other component that we chose was the ball bearing, and this is a very important part in the pump because it allows the impeller and the entire shaft assembly to rotate freely. It also supports the entire axle and the gear as well in this assembly of the pump. So it's a very important piece for the pump to function correctly. Thirdly, the threaded fasteners that are used just are different kinds of bolts, and these both work to cover the motor body and as well as the entire pump assembly, and it also helps keep the parts on the gear shaft and aligned correctly. These bolts also allow for owner or user to easily disassemble the motor if they need to get access to the components inside, because bolts are very easy to take out and put back in. And then I will hand it off to Keegan, who will go over some of the possible design improvements.
So some of the design improvements that we thought for this would be to improve the output by adjusting the drive train to increase the gear ratio. So in this case, we only had a 1-to-1 gear ratio in this part of the pump because it was a gear connected straight to the impeller. So for this, what we would want to do is we would add an idler gear as well as another gear to either help increase the speed of the impeller so that more water would go through the system quicker, or to slow it down so that the water would be able to go in, get as much heat as it could from the engine, and then be able to dissipate that heat later. Another thing that you could do would be to trim the rotor fins on the impeller to increase suction. This process mainly involves the fluid mechanics of the impeller, how the water is drawn into and how it's discharged from the pump housing. And another thing is just to choose lighter material to decrease the weight, not just for the pump, but for the whole motor assembly.
And this concludes our presentation on the Honda CRF 250R water pump. Here are references, and thank you for watching.